Explain in your own words what is meant by the equation the limit of f of x as x approaches 2 is equals to 5. Is it possible if this statement to be true and yet f of 2 is equals to 3? Explain. So the answer for the first question would be the limit of f of x as x approaches 2 is equals to 5 means that if we have a certain function f of x and if we are going to choose values that are close to 2, so as we approach to 2, where would the output is also be approaching? So which is in this case it is 5. So that means as we approach 2 from the left or from the right, so finding those values that are very close to 2 and evaluating it through the function f of x, the result would be 5. So that means it is also approaching to 5. So that is what it means when we say limit of f of x as x approaches 2 is equals to 5. The second question, the answer would be yes, it is possible. It is because if you are going to have a special type of function, a piecewise function, this particular statement could also be true, even if the limit would be different. So say for example this particular graph, let's assume that this is a function f of x. So as you can see, at some point the function has a hole, and the actual evaluation at that point would be changed to other position. So which is in this case, instead of going to 5, it goes to 3. So that is what we have shown here. If we are going to evaluate f of 2, it will give us an output of 3 because that is what is given by the piecewise function. But if we're going to get the limit of this function as we approach from the left to 2, okay, the value will also be approaching to a certain number, which is in this case it is 5, because if we're going to find a number that is closer to 2, so that output of that function will also be approaching to 5. Similarly, on the right hand side, if we are going to approach 2, so the function will also be approaching to a certain value, which is going to 5, and therefore this will give us the limit is equals to 5. But if we're going to directly substitute the value of 2 with the given function, this piecewise function, it will give us an output of 3. Explain what it means to say that the limit of f of x as x approaches 1 from the left is equals to 3, and the limit of f of x as x approaches to 1 from the right is equals to 7. In this situation, is it possible that the limit of f of x as x approaches 1 exists? Explain. So as you can see, the rule for a limit to exist is that the right hand side limit must be equal to the left hand side limit for us to be able to say that the limit exists. So in this case, we are approaching to us the same value, which is 1, but if you notice, we have given the same function, but as we approach from the left, it will give us 3, but if we approach from the right, it will give us 7, which is not equal. So since it is not equal, it is not possible that this limit exists. For the function f whose graph is given, state the value of each quantity if it exists. If it does not exist, explain why. So here's the graph. First, the limit of f of x as x approaches 3. So for us to be able to identify this, we have to analyze the graph. So looking at the graph, x equals 3 can be found here. So that is where we can locate 3. And if we're going to approach from the right, because according to the limit, according to the definition of the limit, the left hand side and the right hand side limit as we approach a certain number must be equal. So as we do that, if we approach from the left, going to 3. So you can see it is going to this particular value, which is this one, this point here, and that is equal to 2. So that means if we approach from the left going to 3, we are approaching also to 2. Similarly, on the right hand side, if we approach from the right hand side, okay, so if we go from the right hand side, we are also approaching to a certain value, which is in this case similar with the left hand side, which is equal to 2. And with that, we can conclude that the limit will be equal to 2. Next, so we have the limit of f of x as x approaches to 2 from the left. In this case, when we are going to look at the graph, as we approach 2 from the left, as you can see, the graph is also approaching to a certain number, which is in this case this point here, and that is equals to 3. So the limit of f of x as x approaches to 2 from the left is equals to 3. So this will be 3. Next, we have the limit of f of x as x approaches 2 from the right. So here, if you're going to approach from the right, so if you're going to look at the graph, it is approaching also to a certain number, which is in this case, it is approaching to 1. Okay, this is 1. And that will be the limit of the function f of x as we let x approach 2 from the right. So this will be 1. Next, we have the limit of f of x as x approaches 2. So in this scenario, we can see that the limit of f of x as x approaches 2 from the left is not the same or not equal with the limit of f of x as x approaches 2 from the right. And with that, we can conclude that the limit of f of x as x approaches 2 does not exist. Okay, so you can write does not exist, but it is not equal. Okay, when we are going to write our conclusion, if it does not exist, is we don't have to put equal sign there, because that doesn't equal to something. We're just declaring that this limit does not exist. Lastly, we have f of 2. So we're just going to directly substitute the value of 2 from the function. So by doing that, we'll be able to see from the graph that if we're going to evaluate 2, it will give us 3. Because this point here, that will be the value for 2 if we're going to evaluate. So these white points, these are actually holes. So that means that values in that particular point doesn't exist. So in this case, it jumped. Instead of going to 1, it jumped to 3. So that's the reason why if we're going to evaluate the function, it will give us 3. Sketch the graph of the function and use it to determine the values of a for which the limit of f of x as x approaches a exists. We have the following function: f of x is equals to 1 plus x if x is less than negative 1, x squared if x is greater than or equal to negative 1 but less than 1, 2 minus x if x is greater than or equal to 1. So this is a piecewise function, and by using decimals, so I got this particular graph of this function. Let's analyze first the graph before we go to the actual problem. So here, this first part here represents the first condition, x plus 1. So that means for values of x that are less than negative 1, this is negative 1 here, and the values that are less than negative 1 are going to the left. So this will be the equation that it will follow. Okay, that is for this particular condition. And the next condition would be values between -1 and 1. So we have -1 and here is 1. So this particular domain will follow the following condition, which will be x squared. So as you can see, it is a curve, it is a parabola. And lastly, for the last condition, if we have x is greater than or equal to 1, so these are values that are greater or equal to 1, so it is going to the right, and it will follow the following formula or like condition. So 2 minus x. So as you can see, this graph here shows that particular condition. So let's proceed now on looking at some of the problems. Use the graph of the function f to state the value of each limit if it exists. If it does not exist, explain why. First, we have the limit of f of x as x approaches 0 from the left. Again, similar on what we did in the previous problem. If we're going to approach from the left, going to 0, so this will give us 0, because that is the point here. So that is 0. Next, the limit of f of x as x approaches to 0 from the right. Similarly, if we're going to look at the graph and we go towards 0, it is also approaching to 0. So the answer would be 0. And we have the next one, the limit of f of x as x approaches 0. Using the definition, if the left hand side limit of that function as x approaches 0 is the same with the right hand side limit of the function as x approaches 0, that means the limit of f of x as x approaches 0 would be the same, and it exists. And in this case, it is 0. Guess the value of the limit, if it exists, by evaluating the function at the given numbers correct to 6 decimal places, and organize the results using the table of values. So you have the following: the limit of x squared minus 3x over x squared minus 9 as x approaches 3. So we're going to use the table of values to do that. So you have given x's here. So we have two values to represent the left hand side and also the right hand side. So let's start with the left hand side. So to evaluate this function, all we have to do is to substitute the value of each of these into the given function that we have, which is x squared minus 3x over x squared minus 9. So let's try the first one. So we have here f of 2.9, that will be equals to 2.9 squared minus 3 times 2.9. So I'm just evaluating here all over x squared, that will be 2.9 squared minus 9. And upon simplifying this expression, this will give us the following output. I get the 6 decimal places to that because that is what is asked. So that would be 0.491525. So this will be the value for f of 2.9. And I'm going to do that to each of these values of x. Also on the right hand side, I'm going to do the same process. And by doing that, I summarize all the results. And this will give us the following. So as we approach to 3 from the left, so you can see here that these are values that are less than 3, but it comes closer and closer to 3, because as you can see, 2.9999, that is very, very close to 3 already. And by looking at its output, it is also approaching to some particular number. So, and that number would be, as you can see, 0.499991. So that is trying to imply that it is approaching to 0.5. Doing the same thing on the right hand side, as we approach from the right, that means we have values that are greater than 3 but very close to 3. So as we approach again, so We go 3.00001, so it's very close to 3 already, but it's not 3. And as you can see, the output is also approaching to a certain number, which is in this case also equals to 0.5. And as you can see, the limit of the left hand side and the limit of the right hand side of the given function have the same limit. Therefore, we can say that the limit of x squared minus 3x over x squared minus 9 as x approaches 3 is equals to 0.5. Use the table of values to estimate the value of the limit. If you have a graphing app software, use it to confirm your result graphically. So you have the first one, the limit of 5 to the power of t minus 1 over t as t approaches 0. So as you can see, we cannot directly substitute 0 here because that will give us an undefined value. And what we can do here is, again, use the table of values to find the limit of this particular function. So here, we can choose any value that can be closer and closer to x from the left, and also values that can be closer and closer to x from the right. So here, I use negative 0.5, negative 0.1 until negative 0.0001. And doing the same evaluation process that we did in the previous problem, this gives us the following result. So for f of x, we got here the following. It is approaching to a certain value, which is 1.6. So if you're going to look at, as we move towards 0 from the left, the function or f of x is also approaching to some value which is equals to 1.6. Looking at the right hand side, so similarly, it is also approaching to a certain value which is the same, 1.6. Therefore, we can say that the limit of 5 to the power of t minus 1 over t as t approaches 0 is equals to 1.6. The limit of x to the power of x as x approaches 0 from the right. So here we only have to use one table because we're just referring to the right hand side limit of the function x to the power of x. And again, I use the same values that are close to x, which is 0, no, from the right. So we have 0.5, 0.5, we have 0.5, 0.1 until 0.0001. And by evaluating each of these values of x to the given function, similarly on what we did in the previous problem, this will give us the summary of the results. So as you can see, the function starting from 0.707106, this is also approaching to a certain value. So this will be equal to 1. Therefore, we can say that the right hand limit of x to the power of x as x approaches 0 is equals to 1. Now, let's look at graphically the results. So as you can see, we have here the limit of the function 5 to the power of t minus 1 over t. So this will be that particular function. That will be f of t equals to 5 to the power of t minus 1 over t. So this is the given function. And if you notice, as we approach to 0, so let's start from the right. So we have here, going for the negative side of the Cartesian plane, going to 0, you can see that it is approaching also to a certain value, which is equals to around 1.6. So that is correct. And as you can see, similarly, if you're going to do to the right hand side, so of this function, as we approach from the right hand side going to 0, so the function also approaches to a certain point or a certain value, which is equals to 1.6. So that is how we can show it graphically. So for the second function, so we have here the graph for x to the power of x. We have f of x is equals to x to the power of x. And notice as we approach x from the right, so we have here our x is 0. So as we approach from the right going to 0, the function also approaches to a certain number which is equals to 1.